Okay, so in this lecture, I want to start talking about valid forms of argument. Um, and I just want to show you guys how this works with symbolic logic and deductive arguments. These are going to be pretty simple. Honestly, some of the more interesting stuff that you can do with this, some of the more interesting ideas it's going to introduce, and the more important stuff is going to have to wait till we get the conditional on the table, which we will after the next lecture. And I just want to introduce the concept and to show you guys how this works. What do I mean by valid forms of argument? How does it work with symbolic logic? Well, let's see. So like I said last time, you can almost think of this like a game, right? You know, one way that sometimes it helps me to think about deductive arguments with symbolic logic is like, well, okay, this is a game. I have these few statements. I have this goal, which is my conclusion. I have different rules, different ways I can get there. Am I able to get there or not following these valid rules? You know, it's a puzzle. Is there a way to get there using only the rules that we see with valid arguments? If there is, then the argument's valid. If there's not, it's not. I don't know. That's the way it helps me to think about this. Might be useful or not to you. Okay, but so let's just go through. Now, we've talked about, I think in passing, maybe in lecture, and I know your book has talked about these valid forms of argument I'm going to cover today. I just want to go back through them. We'll go through some more as we go on, and I want to show you guys how we can use these forms to prove that the argument we looked at last time is valid without doing the whole truth table thing, okay? So let's do a quick review of the forms of argument, then we'll go back into the argument we looked at. So the first valid form of argument is one that your book mentioned. It's the so-called process of elimination. It uses negation and disjunction. P or Q, not P, so Q, right? Statement says you got to have one of these things, P or Q. So if you don't have P and you know P or Q is true, then Q has to be true. So valid argument, right? And with all these forms, you know, when we have a lot of stuff going on, the truth table gets too complicated, too cumbersome. But for these simpler ones, you know, the best way to prove that these forms of argument works is just to look at the truth table, right? So truth table for elimination, we see that, well, you know, when P is false, the only way that P or Q can be true is if Q is true, right? Valid form of argument. From the fact you have P or Q and not P, you know that you have to have Q, right? All right. So if we have not P and P or Q, we know we have Q. So everybody, and it's pretty basic. You know, you don't really need the truth table to understand this, but it's good to go through the definition. All right. Another form of valid argument we looked at a little bit in class, I think a couple of y'all already kind of happened on this one, are De Morgan's laws. And there's two of these, and they involve conjunction and the disjunction. So the first De Morgan's law says not A and B is logically equivalent to not A or not B, right? So from the fact you have not A and B, you also know that not A or not B is true, right? Second De Morgan's law says not A or B is equivalent to not A and not B, right? If you have one of these statements, you can use De Morgan's law to get the other one. And that will be useful sometime. I'll show you guys how. We've touched on this a few times already, so hopefully this shouldn't be too new to y'all, right? So again, to go through the truth tables, not A and B equals or is logically equivalent to not A or not B, right? We know that A and B aren't both true. That's the same as saying either A is false or B is false, right? Look at the truth table. Again, this will prove the logical equivalence. Anytime that not A or not B is false, not A and B is also false. Anytime not A or not B is true, not A and B is also true, right? True and false in exactly the same cases. Every single line, they have the same, what we call truth value, right? When one's false, the other one's false. When the other one's true, the other one is true, right? Same goes for not A or B. Not A or B says, well, it's not true. You can't have either of these. If either A or B is true, the statement's false. So that's the same as saying not A and not B, right? And again, the truth table proves this. Every time not A or B is false, not A and not B is false, and every time it's true, which is really the only one, the last one here, not A and not B is also true. Okay, hopefully these are pretty simple to you guys, and if you have any problems with them, let me know. But we've already touched on these a bit, so I hope it's not too unclear. Final one, and we haven't really touched on this, but it's really not a complicated idea, is so-called double negation. Double negation says, well, if P is exactly the same as not P, right? Think about it. Not P is true only when P is false. So if we're saying not P is false, which is what not P says, then that means P is true, right? Or to think of it another way, just think of the two negation symbols basically just canceling each other out. Whichever way helps you. Just one symbol cancels the other one out. If that helps you to think of it that way, do it that way, right? Either way, I'm not going to give you guys a truth table because I think it's a pretty simple idea. Saying that P or Q or whatever is exactly the same or logically the same as saying not P or not Q, right? Okay. Sorry, the wording gets a little complicated, but if you think about the basic idea, just think of it as the two negation symbols canceling each other, right? Okay. So let's put all this together and run through an argument. We'll run through the same argument we talked about. So Jane will get an A in logic, Mary will get an A in logic, Mary will get an A in anatomy, right? Those are our statements. Our diagrammed argument, either Jane or Mary will get an A in logic, P or Q. Mary won't get an A in both logic and anatomy, not Q and R. Mary will get an A in anatomy, R. Therefore, Mary won't get an A in logic, not Q. So Jane will get an A in logic. Here's our diagrammed argument, right? Our distilled, not diagram, distilled argument, sorry. You know what I mean? You know what I mean, right? Okay, well, so how do we show that this is valid? Well, we actually can with the valid forms of argument we've looked at so far. And here's how. So remember, this is an argument with, it actually has a sub-argument and a final conclusion. So our three premises that are just independent are P or Q, not Q and R, and R. So how do we get from P to those? Well, number 4, not Q or not R, we get that from 2, running De Morgan's rules on that. That gives us this statement, right? Not R, well, we can get that from 3 with double negation because that means exactly the same thing as 3, right? Not Q, well, 4 says not Q or not R, so we have this not R. That means that not Q has to be true, right? We use this process of elimination on 4 and 5 here, right? Finally, 7, we use this process of elimination again, on 6 and 1, right? Not Q. Well, 1 says P or Q1 has to be the case, so this justifies P, right? Now look, I'm not going to be too formal with this, too much of a stickler. If you guys ever do formal proofs in math or more advanced logic classes, you know, or I think even some computer programming classes, they'll be real sticklers about, you have to cite the lines and everything. I just want you guys to know, you know, what the valid forms are, how we're using that to get from 1, 2, 3 to 7. So hopefully this makes sense to you. When you think about it, I mean, it can seem a little complicated as a new idea, but I hope, the basic thought here is simple, right? You have 1, 2, and 3 here. Well, how do you use that to get to 7? Well, you can use these valid forms of argument, these rules. They'll let you get there, right? Okay. So that is all I want to do to introduce the basic idea of valid forms of argument, how they work in deductive arguments. As long as you guys have a basic idea of the concept, that's enough for now, right? We're going to be doing a lot of this. We're going to be doing a lot of practice. I just want to introduce the idea here. So hopefully you have an idea of what this is and how it works. The homework assignment's going to ask you to do this again with a very similar argument. And I'll go over that. We can get some more practice with it.